Hello. Now we would like to, in this lesson, carry out a discussion on functions and relations. And what are functions and what are relations or relationships? So basically, a function is a binary relation between two sets of, or rather two sets that associate each element of the first set to exactly one element of the second set. Now, it's very much like trying to say, a lot of time two quantities are related. Now, sometimes they're related by algebraic expression, like one quantity is 2 times of the other each time, like that. Or sometimes they're related in such a way that, one quantity is always half the other, like relationship always occurs like that. But now in functions, we would like to stick in this type, or rather stick to this type of relation in which one quantity or this in one set, we have one value which specifically it's attached to the other value, or that one value in one set which associates to one other value in the other set. Now, as I indicated, a lot of times this relation is expressed or described by an algebraic expression. So I will be sharing with you a real quick question here so that we can see how we get discussed, rather started on how do we then move on to discuss this type of relations with a mathematical kind of representation. So here we go. Now, what we have here is a set of values starting from -1 to -5. Then, for each set or for each value in the first set, there is a unique and special value that we can get from it in the second set. Now, it will go through a process before we can get the output. Now, notice this -1 to -3, rather -1 to -2 to -3 to -4 to -5. This one forms the first set. And notice that we would like to call this first set of values the input. What we will get right out here after this process of multiplying each of the value by 5, then later adding 20 to it, is going to become the output. So yes, this type of relation in which a set is related to another set with each specific value in one set associated with one specific value of another set is what we call a function. And so how do we use flow diagrams to get us from input to output or from output to input? Now, as I indicated, this set of values is called the input. These other sets of values called the what? It's called the output. And for this case, that is what we are supposed to find. How are we going to do that? We will use what is called the flow diagram. The flow diagram describes how we have to carry out the process to get to the output. Now here we have in the process times 5, meaning each of this quantity of the first set, the input, will have to go through the process of multiplying it by 5, then later adding 20 to it. Well, in a very specific and easy way to understand, we will be having for the first set, we'll be having what? We'll be having -1, which is the first value in the first set, going through a process of multiplying it by 5, then a process of adding it to 20. Now, this will lead us through to the what? To the output. And what is this going to be? Well, we can use a calculator for this, or if it's easy for you to see, then you can really see that it's what? It's 5, rather it's 15. So what we will do is we'll be having -1, okay, this -1 that we have to multiply by 5, then later to it we add 20. That gives us 15. So that means for -1 in the first set, the very specific value which is associated with it is 15. Now notice that this 15 is unique to -1. It comes from -1. Then the next number that we want to deal with from the first set is what? Is -2. And so we write -2. This -2 has to go through a process of multiplying it by 5. Then later we have to add what? Then later we have to add 20. And how do we, well, what do we get from this? Let's see. So we have a 2 that we have to, it's negative, that we have to multiply with a 5 before we can add 20 to it. Now this will give us a 10. And yes, what we see here is that -2, which is a value in the first set, has the output through this process giving 10. So -2 gives 10, and 10 is unique to -2. Now, the next that we want to look at, the next value in the first set is -3. So we would like to have -3 that we do what? That we multiply with 5, because that is the process to go through. Then later to it, we add 20. What do we get from here? Well, let's check what we can get from this. So what we have now is what? Is 3, but it's -3 that we have to multiply with 5 before we can add 20 to it. When we do that, what we get is a 5. So -3 as input gives +5 as output, and we say 5 is unique to -3. Then the next value that we want to include here is -4, that is -4, that we have to multiply with a 5 before we can add a 20 to it. Well, what would this be? Let's check. So now this will give us a 4, but a -4 that we have to what? That we have to multiply with a 5 before we can add a 20 to it. And this will give us a value of nothing or 0. Then lastly, what do we have? Lastly, we have a -5. So here we have a -5 that we have to multiply with what? That we have to multiply with a 5 before we can add a 20 to it. Notice that what this will give us is going to be, well, with the help of a calculator right here, we have a -5 that we have to multiply with a 5 before we can add a 20 to it. This gives us -5. Yes. Now, this set of values that we have got is what we call the output. And sometimes it's expressed as what? It's expressed as a sequence of what? Of 15. In this case, we are starting with 15. Then what? Then 10. Okay. Then 5. Nothing. Then -5. Yes. So this is the sequence of numbers that we have so far got. And these are known as outputs. We would like to call this one output. These are the number that we have used, okay? These numbers that we have used to give us the output, they are known as inputs. They are starting from -1, okay, to -2, then to -3, then to -4, then to -5. These numbers are known as what? They are known as inputs. And now the thing here is, what we said is, with the function, from the first set, we have these values that are associated to a single value here. That gives a function. So -1 is associated to 15. -2 is associated to 10. -3 is associated to 5. -4 is associated to 0. And -5 is associated to this -5. That is what we call a function. Okay, that gives us what we call a function, a binary relation between two sets that associate each element of the first set to exactly one element of the second set. So each element of the first set here has specifically one value in the second set. That type of relationship gives us what we call a function. And how do we get this relationship done? Well, we use flow diagram for this. And yes, now suppose that we would like to extend our discussion of this binary relation. Or even before we do that, yes, this is what we have got right here in the flow diagrams. We now have the flow diagrams. Our flow diagrams has these values of the output right up on the flow diagram there. So now suppose that we want to extend this discussion to the what? To the second activity. Now the second activity right here is saying we represent the function 2x minus 5 on a flow diagram for values of x ranging from what? Ranging from -2 to +2. Now notice that x starts from -2 and we already have it on the diagram here. We have to find the values that are associated to these elements in the first set. Then we have to find and write them here. For values of x as input starting from -2 to -1 to 0 to 1 to 2. Then now the output, they are right here. Well, how do we do that? Well, the steps are a little bit similar to what we just did. So this is going to be using our equation. And what's the equation? The equation is 2x minus 5. So we start with x being negative what? -2. And we would like to use the bracket to take care of the negative. So we'll be writing -2 for x being -2. What do we get for this? Well, we can use a calculator for this. We will be like 2 times what? 2 times -2. Okay, 2 times -2, we close the bracket. All right, 2 times -2. Or is that what we have got? Wait, 2 times -2. All right, then we close the bracket like this. Yes, 2 times -2 minus 5. What do we get from here? This gives -9. So we write it down as -9. All right, so now we move on to the what? Onto the second element in the first set, which in this case is -1. We still use the same formula of what? Of 2x minus 5. Now here, the value of x is -1. And so we would like to put it right there as -1. Now notice that when we do this calculation right inside the calculator, well, what are we going to get? So we'll be having 2 times, okay? And we have 2, but this time what? This time negative, like this. No, it's 1. It's 1, but it's negative. Then we close the bracket. Now minus 5. What do we get for this? We get -7. So yes, this gives us -7. Then we move on to the next, which is, well, using the same formula, x in this case is 0. So the formula is 2x minus 5. So we are going to substitute 0 for x, okay? We are going to substitute 0 for x. What do we get when we substitute 0 for x? Well, we get -5, okay? Which comes this way when we use our calculator. That is 2 times what? Times, not minus, 2 times. Then we open our bracket, we put 0, then we close the bracket, then we put -5. This gives us -5. Then we move on to the next, which in this case, the value of x being 1. So for value of x being 1, what are we going to have? Well, from the expression 2x minus 5, x in this case is 1. So we we would like to put this down as 1. So what is this going to be? That is like 2 times 1 minus 5, which is like 2 minus 5, which is minus what? Minus 3. And then the next is what? The next is for value of x equal to 2. So for value of x equal to 2, we are going to have 2 into 2, then minus 5. This is the same as 4 minus 5. And what is that? That's going to give minus 1. So yes, you notice that each value of x, or each value of the input set of the first set has given us very specific values of the output. So these values that we have so far got, which starts from -9 to -7, then to what? -5, then to -3, then to -1. These ones, this set of values are called outputs. Okay, we would like to call them output. And then these other values that we have used to find the output, they are known as inputs. And they are ranging from what? From -2 to -1 to 0, then to 1, and to 2. These values here, also known as the values of x, are called the inputs. So now the function bit comes in this way, that in this first set, there are elements, and each of these elements is associated to one specific element of the second set. That type of relationship is what we call a function, a binary relationship in which one set or the elements of one set has got very specific values they associate with in the second set. How do we get them? We follow the flow chart. We follow this flow diagram to get to that. Okay, so the flow diagram here is that we multiply this by 2, then from it we take away 5. So it has been given here, and that is how we got this. Now, what else is remaining? Well, we have to plot it onto the flow diagram, and putting this one onto the flow diagram, what do we get? Well, when we put this onto the flow diagram, this is what we get. The flow diagram gives us this. And here is a task for you. Now, your task is to represent this function, okay? Is to represent this function, which is what? Which is minus 3x plus 4 on a flow diagram, and values of x ranging from -2 to +2. Now, that is what you're going to be doing. You represent the function -3x plus 4 on a flow diagram for values of x ranging from -2 to +2. And as soon as you're done with that, you have to make an effort to do what? To submit your exercise. And that's where we are stopping for now.